Classifying triangles. We can classify triangles according to sides or according to angles. So this first chart that you have in your notes is about classifying triangles according to their sides. So our first one is an equilateral triangle. You see the word equal in equilateral, don't you? Okay, so that just means that each of these sides are the same length. All three sides of my triangle are of equal length. Draw yourself an equilateral triangle. And it doesn't have to be perfect, but you have to have, if you have those little marks there on the sides, those marks indicate that each of these sides is equal. For an isosceles triangle, only two of the sides are of equal length. This third side has 2 marks on it because it's not the same length as the sides that have 1 mark on them. A scalene triangle, none of the sides are equal. They are all of different lengths. So go ahead and draw an example of an equilateral triangle, an isosceles triangle, and a scalene triangle if you haven't done so yet. Then I want you to fill out the descriptions. And pause the video and I want you to fill in those descriptions, see if you can do it just because of the drawings and of what we talked about. And then once you've done that, start the video up again. All right, hopefully you wrote that in an equilateral triangle, all sides are equal. In an isosceles triangle, 2 sides are equal. And in a scalene triangle, no sides are equal. So once again, this is naming triangles according to their sides. We can also name triangles according to their angles. Okay, so our first one is an acute triangle. So I think you're all familiar with what acute angles are. Acute angles are angles that are less than 90 degrees. So what you want to draw is a triangle where all angles are less than 90 degrees. A right triangle has 1 right angle, and an obtuse triangle has 1 obtuse angle. Okay, please draw these out on your own. So if you think about it, you can't have a triangle that has more than 1 right angle because there's only 180 degrees in a triangle. And if you have 1 right angle, which is what I have right here, and you subtract 90 degrees from 180, you only have 90 degrees left to share between these other 2 angles. So you can only have 1 right angle in a right triangle, or in a triangle at all. And the same goes for obtuse. Let's say that you had this 1 angle and it was 110 degrees. It's hard to tell that by my writing. This is not that easy to write on. But if it was 110 degrees, you'd only have 70 degrees left to share between these 2 angles here. Okay, so once you have drawn your pictures, you want to write your description. Acute, all angles are less than 90 degrees. Right triangle, 1 angle is 90 degrees. And obtuse triangle, 1 angle is greater than 90 degrees. And just as a reminder, how can you tell if there's a right angle inside a triangle? They're going to make this little corner right here. I'm going to erase it and draw it again. They're going to make a corner right here to show you that is a 90-degree angle. Lesson 94 is about writing fractions and decimals as a percent. So what does percent mean? This is a review. Percent means per hundredth. Because we do remember that cent is like century, it's like penny, right? Pennies, there's 100 cents in $1. So that helps us remember that percent means per hundredth. And that's why in previous lessons, when we talked about this, we had something like 4/5. We changed it by multiplying by 20 over 20 to get 80 per hundredth. And we said, okay, so since we have it in that form, we can say 80%. However, in this lesson, we are going to be doing percents that don't work quite that easily and quite as simple as those in the previous lesson. So let's talk first about how to change 1/3 to a percent. There's more than one way to do this, and I'm going to show you two ways. So either you can multiply 1/3 by 100% and then divide. Okay, we'll do that first. 1/3 times 100% over 1. We can't cross cancel here because 3 does not go evenly into 100. So we just rewrite it as 100% over 3. And now we can divide that 100% by 3. Okay, 3 doesn't go into 1, but it goes into 10 3 times. We subtract, we get a 1. And now we're dividing 10 again. So we can see that this will just go on and on. So instead of writing a decimal answer or anything like that, we are going to put our remainder over the divisor and make a fraction. So 33 1/3%. Okay, so that's one method. I have written there multiply by 100%, and that's this example is what I intended for you to write in that area. Okay, so the second one says change to a fraction and then multiply by 100%. All right, so let's try that. Actually, I wrote change to a fraction and multiply by 100%, but I meant change to a decimal. It's already a fraction. All right, so let's change it to a decimal by dividing the numerator by the denominator. Well, we'll get the same thing, of course, 33 1/3, but we have it as a decimal, so it equals 0.33 1/3. Okay, so all we've done here is we've changed 1/3 to a decimal, 0.33 1/3. Now we have to multiply it by 100%. And when we do that, that tells us we need to move our decimal point over twice. So it becomes 33 1/3%. Okay, because remember, when you are multiplying by a power of 10, the number of zeros there tells you how many times to move your decimal point. In this case, we have 2 zeros, so we have to move our decimal point to the right twice to make the number larger. But of course, 33 1/3% is one part of a whole. Like you have a whole, so 33 1/3% is equal to 1/3 of it. Okay, it's less than all of it. But what happens if we have 1 1/3? What does that equal? Well, that means we have this section here plus one more. Okay, of this pie or pizza or whatever it is, delicious cookie, we have all of it. That's 100%. And of this one, we have 33 1/3%. Okay, so we can simply add those two together, 100% plus 33 1/3% equals 133 1/3%. Another way we could have done this problem here is to make it an improper fraction. And if you recall, we do that by multiplying the denominator times the whole number. Okay, that's multiplication, and then we have to add the numerator. Well, 3 times 1 is 3, plus 1 is 4. So we end up with 4 over 3. And then we can use one of the methods that we looked at before. So let's multiply it by 100%. So we get 400% over 3. And now we can divide. 400% divided by 3. Well, 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 is 1. Bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. Subtract. Get a 1. Bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. Subtract. You get 1 left over. And we're going to use that as a fraction, 33 1/3, and we don't want to forget our percent. It's more than 100%. So you will have some problems that are like that in this lesson. Let's look at the examples that I gave to you to solve. We're not even going to do the first one because we already talked about that one. But let's look at the second one. Most of you probably remember what 1/4 is as a percent. But since I don't have you in class and I can't ask you, we're just going to calculate it as if you didn't know it. So in order to calculate this, let's change it to an improper fraction. Well, 4 times 2 is 8, and 8 plus 1 is 9. So 2 1/4 is 9 over 4. Now, we have two options. We can divide first, or we can multiply first. I choose to multiply first. If you were with me in class, I would let you choose, but right now, I'm by myself. So 9 over 4 times 100% equals 900% over 4. We can put a 1 there just to make us feel better. All right, so what is 900% divided by 4? Well, 4 goes into 9 2 times. 2 times 4 is 8. We subtract, we get 1, and bring down the 0. I'm running into my other writing. 4 goes into 10. How many times? Twice. 2 times 4 is 8. Subtract. We get a 2. Bring down the 0. How many times does 4 go into 20? 5 times. 5 times 4 is 20. Subtract. No remainder. So we find that 2 1/4 is 225%, which I bet you guys knew that 1/4 was 25%. And 2 times 100% is 200%. And if you add those together, you get 225%. Let me erase till I can clear up that area. Okay. How about 1.2? These are a little bit easier because now you can just multiply. Multiply 1.2 times 100%. Actually, I'm going to change my colors. Let's use green. 1.2 times 100%. Well, we just move that decimal point over twice, and we find out that that equals 120%. Okay, this here looks like 5, but it's supposed to be 0.5. Well, what is 0.5 as a fraction? It's a half, right? So that helps us think through what 0.5 would be as a percent, or you could have just said 0.5 times 100% equals, move the decimal point twice, 1, 2, 50%. Okay, .06, well, once again, let's multiply by 100%. That means we move the decimal point over twice, and we find that .06 is 6%. That's a very small amount of something, isn't it? This next one's kind of interesting because it's .125. Well, 0.125 times 100%. We have two zeros here, so we're just going to move the decimal point twice. We're still going to have something left after that. So we find that 1.25 equals 12.5%. It could also be written as 12 1/2%, similar to 1 1/3. I want y'all to finish the practice problems on your own. Let's go ahead and look at the very last one, though. It says, what percent of a foot is a yard? What percent of a foot is a yard? Well, if 1 foot equals 3 yards, okay, then what we can know is that, let's talk about what it is as a fraction. All right, your last question says, what percent of a foot is a yard? Well, this is a little bit embarrassing because I made a mistake there. What I should have asked you is, what percent of a yard is a foot? All right, we know that there are 3 feet in 1 yard. So 3 feet equals 1 yard. All right, so in fraction form, we would say that a foot, 1 foot, is 1/3 of a yard. Okay, so once you have it in this form, it's a whole lot easier to solve. Okay, because we know what 1/3 is. It's 33 1/3%. Okay, you do need to put these common percentages into your memory bank. Things like 1/4 or 0.25, both equal 25%. You need to know what 1/3 is. You need to know what 2/3 is. Okay, and your time tests should help you with that. Do the rest of the practice problems on your own. Lesson 95 is about reducing units before multiplying. The nice thing is we have already discussed this, so this should not be anything new or anything too difficult. It's nice to have a simple lesson every now and again. We've talked about the fact that just like with numbers, we can cross-cancel. The same is true with units. And when we do have units that we're converting and we're changing the units in some way, we always want to make sure that we cross-cancel. So here I've got hours, and there I've got hours. Here it's in the numerator. I'll write that over 1 so we can see that better. And here it's in the denominator. Okay, so we can cancel those out. There aren't any other miles to speak of, so now we can just multiply 55 by 6. Well, let's just write that out to the side. 55 times 6. We know that 6 times 5 is 30. 6 times 5 is 30 plus 3 is 33. So 55 miles times 6 hours equals 330 miles. And it makes sense, right? If you're traveling in the car for 6 hours and you're driving at 55 miles per hour, that you would be able to cover a lot of ground, right? You can go 300 miles. It's a good ways. Of course, we tend to travel faster than that nowadays. All right, the next one says multiply 5 feet by 12 inches per feet. Well, let's write it out as, here I'm going to go back to black and write 12 inches per foot. That's how we write that. Remember that division line. It can be used, we can use the word per for that. 12 inches per foot times 5 feet. Okay, there's no per there, so let's just put a 1 under it. We can cross cancel our feet. And now we're just left with inches. So 5 times 12 is 60. That's probably a multiplication fact, you know. 60 inches. Okay, so what we just did was we took a measurement that was in feet and we changed it to inches. All right, the next one, $30 per 1 hour times 8 hours. That would be like, $3 per hour. That would be like a rate. That is a rate that you might be paid per hour. That's not a legal rate today, but if you were paid $3 per hour, and we're writing out the word dollars, I think, so that we can see that we have 2 units here. And we're going to multiply that by 8 hours over 1. So in 8 hours at $3 an hour, you could earn $24. Okay, that's way below minimum wage. So that would definitely not be a good thing. All right, I'm going to let you guys work through those. Actually, let's do one more. I'm looking at them and I'm seeing the one that says 10 cents per kilowatt hour. Okay, so that's how we measure energy, is in kilowatt hours, and I put an R there, but on my paper I just have kWh. And we're going to multiply that by 10 hours. Okay, presumably these are kilowatt hours. All right, so 10 times 10 cents equals 100 cents, or $1. Okay, so you could write it as $1 or you could write it as 100 cents. I think the rest of those you guys can handle on your own. All right, here we get into some more algebraic types of problems in Lesson 96. And it's about functions and graphing functions. And in your notes it says, a function can be thought of as a rule that produces one output for every input. For example, what could the following function represent? P equals 4s. I'm going to use blue. P equals 4s. Okay, if we were in class, I bet someone would come up with an idea. It is actually, this function here is referring to perimeter. The perimeter of what? Equals 4 times s. The perimeter of a square. Okay, the perimeter of a square equals 4 times the length of the side. Okay, so that's a function. So if your side is 1 inch, your perimeter is 4. Okay, so if s equals 1, P equals 4. All right, so we're not going to get a different P if we use 1. We'll always get 4. Okay, so that's what it means when it says there's one output for every input. This is our input, and this is our output. Okay, or in the equation, the S is our input, and the P is our output. Okay, so now the rectangle that you see on your sheet is simply that same equation put into rectangle form. So I'm going to write our equation right above it. P equals 4S. So when S is 5, okay, if we put a 5 in there for S, we say P equals 4 times 5, which is 20. So that's where this 20 comes from. All right, how about when S is 7? Well, P equals 4 times 7, which is 28. Okay, so we would write 28 there. So when S is 10, if the length of the side is 10, what will our perimeter be? Well, 4 times 10 is 40. And how about if S is 15? The length of the side of our square is 15. What will be our perimeter? Well, 4 times 15. 4 times 5 is 20. Carry the 2, and 4 times 1 is 4. Plus 2 is 6. 4 times 15, you can think of the hands of the clock. There's 4 groups of 15 minutes in 1 hour. So it makes sense that 4 times 15 is 60. All right, so the next question in the notes says, is it possible to get a different P for the same S? We've kind of already discussed that. This is a very important part of functions. Each input can only have one output. I know I'm repeating myself there, but that is a very important part of being a function. So the next one says, find the rule for the following function. And what I'm referring to is the L and the M. Okay, so you have a chart, and it says L, and it says M. Okay, and I don't tell you what that means, but I do give you numbers. So if L is 5, M is 20. If L is 7, that's what you have to figure out. What is M? If L is 10, M is 25. I'm going to redo that. L is 25. And if L is 15, M is 30. Okay, so what we have to figure out is what is happening each time. Well, it doesn't appear to be any kind of a multiplication function because 4 times 5 is 20, but 4 times 10 is 40. So that doesn't make sense for this function to be multiplication. So then we have to think of addition. Well, what plus 5 equals 20? Well, 5 plus 15, right, equals 20. Does that work for this one? 10 plus 15 equals 25. Oh, good. Well, let's just make sure. 15 plus 15 equals 30. So we have figured it out. And that means that we can come back and answer this unknown. What is 7 plus 15? It's 22. So we can write 22. So if we were going to write this as an equation, how would we do it? Well, we are finding M, right? M is equal to our L plus 15. And could we graph these functions? Wouldn't that be kind of fun? Let's see what happens when we try to graph that function. Well, we can make ourselves a nice little graph. Okay, we're going to say that this one is M and this one is L. So when L is 5, I'm going to mark these by, let's mark them by 5s because we have 5, 10, and 15. So let's say that's 5, 10, 15, 20. And we can do the same on our M side because we can measure these however we want. 5, 10, 15, 20. We're only dealing with positive numbers, but we do go up to 30. Okay, so when L is 5, remember the horizontal is our L, M is 20. And we go up and we put a dot there where those two things cross. When L is 7, M is 22. And here we have to kind of say, we're going to just estimate. 7's right about there. So I'm going to come up here, and 22 is probably right about there. We just estimate on these. When L is 10, M is 25. That's pretty easy to see. And when L is 15, M is 30. Whoops, I did not mean to make that line there. There's my 30. I'm going to erase that line. Okay, so now we can take a straight edge and draw ourselves a line. I'm using my phone as my straight edge. See if that works well. Not working so well. Okay. So that's basically a picture of this function. M equals L plus 15. All right, the next one says find the missing number in the function table. So this one gets even more algebra looking, right? So we have an x and a 3x minus 2. I'm not using my straight edge, but that's okay because you guys are pretty forgiving. All right. So they have x is 2. Okay. So in this function, what they want us to do is they want us to figure out what happens here, what happens when we put a 2 in for the x. Well, 3x minus 2 means 3 times whatever x is, minus 2. Well, this time we're saying x is 2. I'm going to put my x's in blue. So what is 3 times 2 minus 2? Well, 3 times 2 is 6. Minus 2 is 4. So what we can do is put in our other row that 3x minus 2 is 4. How about when x is 3? Well, once again, we're going to substitute the 3. We're going to put the 3 in place of the x in that equation. So we'll write 3, parentheses, 3 minus 2. 3 times 3 is 9, minus 2, 7. So when x is 3, our equation, our function is 7. Let's undo that. Let's do it in black. Be consistent. Okay, how about when x is 4? Then our function, or our y, would be 3 times 4 minus 2. Whoops. All right, which equals 12 minus 2, which equals 10. So when x is 2, our function is 10. Whoops, change colors, 10. Now how would that look on a graph? Okay, You can draw your X and your Y. Remember, Y is our vertical and X is our horizontal. We're not dealing with any negative numbers. We're only dealing with positive numbers. So 1, 2, 3, 4. Those are the numbers on X that we're using. Whoops. That should have been a 3. And on our Y-axis, we need to be able to go up to 10. So I'm going to say 2, 4, 6, 8, 10. And we know that our in-between numbers are going to be the odd numbers. So when X is 2, I'm going to make my dots with red. When X is 2, Y is 4. When X is 3, Y is 7. Okay, that's in between 6 and 8, so I'll just put a little dot there. Whoops. Ended up making 2 dots, didn't I? When X is 4, Y is 10. Okay. This is what we call a linear function because it makes a line. Once again, I'm using my phone as a straight edge. A ruler would work better. Okay, that's how we graph that. What I would like for you to do, and I wrote this on your practice page, or on your notes page, go to page 515 and do those practice problems. You can see how they did the sample problems as well. And if you're confused at all, you can go back. This would be a very good lesson for you to read on your own before you do the assignment and even before you do the practice problems. As always, I'm here to answer any questions you might have.